Okay, so if you're joining us from home, we just started on the practice sheet. It looks like this. This is the one for Tuesday, predicting products and writing reactions. So they are starting on number 1, and it says write a reaction for the combustion of hexane, which is C6H14, and balance the equation. So what they also have, most of them on their desk, is their little flat book. Okay, this is what we made in class. You could just use the template and keep it on the sheets, or you can make a book out of it, which is what some of them did. So anyways, what you would do is find combustion. You look for the combustion sheet, and it will tell you how to write your combustion reactions. Okay, so with combustion, you should always be starting with some sort of a fuel source, right? So let me find a good marker here. Oh, okay. So we've got our fuel source, which is C6H14. That's a hydrocarbon, C6H14. Now, in combustion reactions, we know combustion reactions always produce heat and light, okay? And so those guys that are working on that one, combustion also has to involve one other substance. So everybody out there in class 1 here, what's the other gas that you would have to have present in order to get fuel to burn? Dagan? Oxygen. So in order to make fuel burn, you have to have oxygen present. And then according to our little books that we made, we know that the products of combustion are always the same 2 things, or at least for the combustion reactions that we write in Chem 1. What are the 2 products, Dylan? What are the 2 products? Perfect. Okay, carbon dioxide and water, CO2 and H2O. And listen, all combustion reactions are going to look like this. The only thing that will change is going to be the fuel. Okay? Combustion reactions are some of the easiest ones to write because you know it's going to have fuel and oxygen, and then it's always going to produce the same 2 products. So combustion reactions are fun to write, and they're easy because you know what to expect. The only thing now that you have to do is to balance the equation. Okay, so with this equation, when we balance it, you can make a list if you wanted to and list out your carbons and hydrogens and oxygens. I think I'm going to work through this one and we'll see if we all got it right, okay? I would check my reactant side and say, how many carbons do I have? Everybody, how many do I have right now? 6. Over here, I want it to be 6, so I'm going to put a coefficient in front of the carbon. So now my carbons are good. I have 6 and 6, okay? If I keep moving across, because I'm going to come back to the beginning and go from left to right, I look at my hydrogens now. On this side, I have 14. On this side, I only have 2, but I need it to be 14. So I'm going to go ahead and put a 7 right here. So now I have 7 times 2 is 14 and 14. So that's good, okay? Now on my oxygen side, I have 2 right here. On this side, you have to take into account that you have 2 sets of oxygen here. So this one right here, how many oxygens do I have in the CO2, guys? 12 plus 7, good. All right, so we have a problem again, okay? How in the world are you going to get this to be 19? Well, think about what would 19 divided by 2 have to be? What would we have to multiply 2 by to get 19? 9.5. You can't do it by 9 because that's just 9 times 2 is 18. You can't do it by 10 because that would be too many, 20. So 9.5. Now, if you're at home being like, you can't do that, Miss Lovell, I know. Okay, so we're going to fix it. And so what we've been practicing this morning is if you have a fraction as a coefficient, you don't want to leave it like that. So instead of having a fraction, what should we do here? What do you think? Anybody? Yeah, go back to the beginning, multiply all of your coefficients by 2. So we're going to start back at the beginning, and instead of having one of these things, I'm going to have 2. Instead of having 9.5, I'm going to have 19. Instead of 6 right here, I'm going to double it and have 12. And instead of having 7, I'm going to have 14. Okay? And if you wanted to prove to yourself that you really did do it right, just go back and check your math. Go back and check everything. Okay? So how many carbons? 2 times 6 would be 12. Over here, look, I have 12 carbons. 2 times 14 would be 28 hydrogens over here. 14 times 2 is 28. And then your oxygens, 19 times 2 would be 38 oxygens, right? Yeah, okay. 38. And then 12 times 2 is 24 plus 14 would be 38. Okay. That, to me, doing it like that to where you put the fraction in there and then just go back and double all the coefficients, I think that's the easiest way to do those. So try that out. It just takes practice. Okay. So that's a combustion reaction. Do anybody have any questions about number 1? Does that make sense? Okay. So now, looking at number 2, have you guys started number 2 yet? Did you try it out? Kind of, sort of? All right. Looking at number 2, it says write the balanced equation for the reaction between hydrochloric acid, which is HCl, and sodium hydroxide. Balance the equation and identify what type of reaction it is. So we've got 3 things we need to do here. We have to write the equation, okay? We have to balance it, and then we have to identify the type that it is, okay? So let's start this. If you're going to write a chemical equation, you've got to come up with what you start with and what you end with. So looking at number 2, what would the reactants be? What would the starting substances be?
Hydrochloric acid and sodium hydroxide.
Very good. Hydrochloric acid and sodium hydroxide. That's what I'm starting with. That's what's reacting. HCl and NaOH. Okay? So now what do? You have a compound. This is a compound and a compound. You have multiple things. You have multiple capital letters. You have a compound and a compound. This almost looks like it would be something like this. AB plus CD, right? Because you have multiple things here. What type of reaction are we looking at, guys? If you have AB plus CD. Double displacement. Very good. Okay. And by the way, if you didn't hear Jacob a while ago, he did ask a pretty good question. Some sites and some books will call them double displacement. We call them double replacement. Just depends on what textbook or what website that you're reading. But they mean the same thing, replacement and displacement. Okay. So having said that, then, in double displacement, what things will switch places? What did we write down in our flat book for double displacement? Yeah, good. Like the front things, right? The A and the C. The front things will switch places. This is known as, or those are known as cations. The cations, the front things, typically switch places. So if this is a cation and this is a cation and they switch places, they're going to hook up with new partners here. Can you tell me what would the products be, do you think, here? Okay, they can try it.
Sodium chloride, water.
Very good. NaCl and HOH or H2O, right? So, and you could write it like either one, because if you're just taking this hydrogen and you're swapping them, it would look like HOH, but of course we know that's water, H2O, right? Okay. So this, by the way, is an acid-base reaction. This is a strong acid and a strong base, and it always acid-base neutralizations produce some sort of a salt and water, H2O. Okay. Now take a look at this reaction. It also asks you to balance it. So take a look at it, see if you can balance it. They're sweating bullets. You guys should see them. They're working hard. Peyton says it's already balanced. Does anybody agree? It is. It's already balanced. Let's double check it. Let's fact check Peyton. Make sure he's right. All right. I'm not going to start with my hydrogens. You should always try to save hydrogen and oxygen till last, okay? So let's skip that and look at our CLs. How many CLs do you have on this side? 1 and 1. Good. Sodiums, you have 1 and 1. Now, let's do our hydrogens and oxygens. We'll go back to the beginning. On the whole side here, you have 2, right? Look on this side. How many do you have? 2. Right there. There's 2. And then you're looking for O's. You have? And very good. 1 and 1. So it's already balanced. You didn't have to do anything. No coefficients. So everything is in a 1-to-1 ratio. Okay, 1-to-1 to 1-to-1. All right, so what type did we call this? What kind of reaction is this? Double displacement. It's a double displacement reaction. Dungeons and Dragons, whatever. DD. Okay, D&D, I guess. All right, so good. Questions about that one? Okay. I do not want us to work number 3. Like, I don't want to work that one with you because we've already done a combustion reaction, and I feel like you guys could probably do that if it was combustion. I'm not saying that it is, because you've got to identify the type. It might be. I don't know. Okay. All right. So let's move on down, though, let's look at number 5. Let's actually look at number 5 at the very bottom of the page. It's 8:42, by the way. We've got 3 minutes. So potassium chloride reacting with oxygen gas will produce potassium chlorate, which is KClO3. Write the balanced equation and identify the reaction type. Okay, so we've got to write the balanced equation. So we've got to have an arrow, and you have to figure out what's going to go where, right? So can you tell me, do you know what the reactants are? Dagan's shaking his head yes. Does anybody else know? Peyton says yes. Yeah. KCl, potassium chloride, is reacting with oxygen gas. Peyton said to write oxygen gas, you've got to write O2. You can't just write it as O. And if the bell rings, by the way, I'm going to stay in here and finish this problem. So I'll be talking to myself. If you want to stay and get the rest of this, you can. Okay. All right. Yeah, and that's fine. If you've already got it done, you're good. All right, but this is KCl and O2. It yields, it says it reacts and will produce potassium chlorate. And they tell you potassium chlorate looks like this, KClO3. Okay? And it says write the balanced equation. So look, here's our equation. We've got everything listed that we need to have. Okay? And then if we go to balance it, I'm just going to kind of talk my way through this one. I start over here with my left. I have 1K here and 1K here. 1 Cl here, 1 Cl here. Here is my problem. I have 2 of these and 3 of these. So when you have something like that, how would you get them to be the same? You what? Yeah, you need like something to multiply to where you're going to get like a least common multiple, right? So what's the least common multiple between 3 and 2? 6, right? They would both go into 6. So figure out how you would get this one to go into 6. I would put a 3. This oxygen, to get that to be 6, I would put a 2. Now you're not done. You would have to go back and put a 2 right here, because now you have 2 sets of KCl, so I would put a 2 there. Okay, so if you're...
in the office, Mikey Larson said Lumen, Carmen, and Kieran.
Hi, idiot. Hey, so by the way, though, what kind of reaction does this look like? Synthesis. Very good. Nice job. So the type is synthesis. And we know that because you have A plus B yields AB. You have 2 things that would make 1. Okay. All right. And that would be it on number 5. It's just asking you to write the balanced equation, give the type, and that's it. Okay, listen, that's all that we did in first hour. I told them that we would work 3 of them together. So you have 3 examples of 3 types of problems. You need to try to do the other 4 and see what you can come up with, okay? Please don't just Google the answers. Try to figure these things out. If you have questions, let me know, okay?